All right, this is 1-6 continued. We're going to talk about solving absolute value inequalities. And two key words that I want you to remember, and look how I've got them written. Less than, you want to think and in the last video we talked about any and compound inequality. If it's had and, it was shading between. And any or, we say greater than, but that's really not the way you spell greater, right? But I want you to think of it this way. Greater or would mean shade away from each other. So when you're doing absolute value inequalities, you can think of this to be like a short trick in how you're going to shade your answers. So first of all, you have to recall that when you solve the absolute value equations, that there were two values or two solutions a majority of the time, except for those special circumstances. But most of the time, there were two solutions. So when I look at an example like the absolute value of D is less than or equal to 4, I try to think of that as an equation in my head. And I say, well, what would I plug in here to make the absolute value equal to 4, even though it's not equal? I just think this way. Well, I could plug in 4 or negative 4. So that kind of gives me my starting point of how I'm going to graph this or how I can find my answers. If I say 4 and negative 4, here's negative 4, and here's positive 4, but both of those would give me a value that is equal. If I plugged them in and found the absolute value, it would equal 4. So now I'm looking for, well, which values would give me less than 4? Which absolute value? And remember, absolute value is a distance. So if 0 is here, and I have 1, and I took the absolute value of 1, that would give me a value less than 4. If I did negative 2, its absolute value is less than 4. Negative 3, its absolute value is less than 4. Positive 3. So these values in between here work. But if I said 5 and I plugged in the absolute value of 5, plugged in 5 and got the absolute value, it would be greater than. So 5 would not work. So once I get past 4, nothing works over here. Also, if I plugged in negative 5, that would not work either. So the values I need are in between, and I also need an open dot on both of these values here, but it's in between. Now, if you look back up here, this is a less than sign, so if you think less than and, you think in between, and look, we shaded in between. Okay, let's try another one. The absolute value that would give me equal to a 3 would be a positive 3 and a negative 3. So if I were to draw my number line, and I have a negative 3 down here and a positive 3 here, and I say, well, what values can I take the absolute value of to give me something greater than the 3? So we know that the negative 3 and positive 3, when they're plugged in, that they will give me the equal to the 3. But, so I can go ahead and close in a dot here. I know that those work. But if I try a value in between 3 and negative 3, like 0, well, 0, the absolute value of 0 is 0, and that is not greater than 3. So numbers in between here don't work. If I try a number on the left side of negative 3, like negative 4, absolute value is 4, and that is greater than 3. So I can shade this direction. And if I tried a number on the right side of positive 3, like 5, the absolute value of 5 is 5, and 5 is greater than 3. So look at this. It says greater, shading away. So this symbol greater than is going to help me figure out to shade away. All right, the next one. Now remember earlier that we talked about the absolute value could not equal a negative number. But now that we're talking about inequalities, think about the absolute value once you took it. When will it be greater than a negative number? It'll never be equal to the negative number, but this is greater than or equal to. So if I put in a value 6, and I took the absolute value of 6, that will be greater than a negative 1. If I put in a negative 2, the absolute value will always be greater than negative 1. So this has infinite solutions. This is all real numbers work. You could also say infinite solutions. If it has just greater than, so the absolute value of x is greater than a negative 5, well, it's always going to work because the absolute value of whatever you're taking here is always going to give you something greater than this negative value. Okay? The opposite is true for less than. If you're asking, hey, when are you going to take the absolute value of some number and get less than a negative 6? Well, that's never going to happen because we are already saying if we take the absolute value, the value should be positive. And so if you're asking me to take the absolute value of something and it's going to be less than a negative number, that's not going to happen. So this is going to be no solutions or no solution. Or you could also write the empty set or the null set. And then last but not least, actually we have another problem on the back too. In this problem, you want to set up the two, I think about it as doing the two equations like you would have done with equal signs, but this time it's just with inequalities. So we will do 2x, notice that the absolute value is already isolated, 2x minus 2, and I'm just going to set it up as equal to, because I don't want to think about the signs and all of that. So I'm going to say equals 4, just make it easier on myself. And then I'm going to say 2x minus 2 equals negative 4. Remember that? You had to have the positive and the negative version. Now solve both of these. Plus 2, 2x equals 6, so x equals 3 here. And on this side, we get 2x equals negative 2, x equals negative 1. And now what I do is I go back and look at this symbol. And because I didn't have to change the symbol, I did not have to divide by a negative number on the outside here before I even started solving. Because I didn't have to do any of that, this right here says greater than. So I'm going to line up my numbers from the least value to the largest value, smallest to largest. So the smallest is negative 1, the largest is 3, and I go back to this symbol and say, okay, it's equal to, so I'm going to do a closed dot. And since I read this as greater than or greater, shade away. Now you can solve this by using the inequality symbol, but you have to be very careful. If you do 2x minus 2 is greater than or equal to 4, just like it's written, you'll solve that one. But the other one would be 2x minus 2 is less than or equal to negative 4. And the reason is because if I change this value over here to be negative, I have to flip the sign just like if I were solving and I made it negative. And so in this case, add 2, 2x is greater than or equal to 6, x is greater than or equal to 3. And so if you look back here, that corresponds with this section here, x is greater than or equal to 3. And then plus 2, 2x is less than or equal to negative 2, x is less than or equal to negative 1, and that corresponds with this section. So you can choose how you want to solve it. I like doing it as an equal sign so I don't have to worry about making sure that I've flipped my sign. Let's do one more. So 4t minus 3 is equal to 7, and 4t minus 3 is equal to negative 7. If I add 3 to both sides, 4t equals 10 divided by 4, and t equals 10 over 4, and I can reduce that. T equals 5 over 2. On the other side, we have 4t equals negative 4, and so t equals negative 1. These are my two values. Again, line them up from smallest to largest, negative 1 and then 5 over 2. They each, going back up to this sign, they each get a closed dot because it's got an equal to. And then we'll say, okay, this says less than, so less than, and. In between is where we'll shade. Again, if you solve it the other method, 4t minus 3 is less than or equal to 7. That's exactly how it's shown, just without the absolute value bars. Or 4t minus 3 is greater than or equal to negative 7 because I made this negative, flip the sign. Now solve. Plus 3, 4t is less than or equal to 10. T is less than or equal to 5 over 2. Okay, that would be the 10 over 4. I've already done all that. I don't need to show that again. But t is less than or equal to 5 over 2. Well, we're going less than, and we're equal to, the 5 over 2. Plus 3, 4t is greater than or equal to negative 4, and so t is greater than or equal to negative 1. T is greater than or equal to negative 1, greater than or equal to negative 1. So both of these ways works. Hope you enjoyed that. Have a good night.